Welcome to Hybrid Container Days, and my name is Daniel. I'm going to talk a little bit about Zero to Hero in Kubernetes native Java. Let's get started. Again, my name is Daniel. I'm working for Red Hat as a developer advocate with specialized cloud-native runtime, for example, Quarkx, Spring Boot, Node.js, and also I spend a lot of time to integrate existing cloud-native runtime into serverless and service mesh and GitOps practice and Kubernetes platform. As a part of the CNCF ambassador, I'm really love to have some conversation with the cloud native development as well as cloud native architecture and so on. So here's my contact information. Just so you can feel free to reach out to me directly. You can follow my Twitter and then pin the URL Daniel TV, my YouTube channel. There are more than 100 tutorial demo and technical videos. And then here's my GitHub repository. You can feel free to reach out to and clone any technical example to build your cloud native application. Today I'm going to showcase Quarkx for cloud native Java application development. So what is Quarkx? I'm pretty sure a lot of developers and most of you already know and heard about what Quarkx is for, because Quarkx was born 2.5 years ago, specifically optimize your Java application running on Kubernetes. Quarkx fundamentally enable Java developer to optimize your Java application on the Kubernetes with a lot of great developer experiences and then optimization. For example, you can run native Java application on local machine, but also Kubernetes cluster. And you can also evolve existing Microsoft application with the Quarkx for serverless application with the event-driven architecture. This illustration showcases how to get started your Kubernetes native Java application development from scratch, and in the end, you're going to become hero and a super expert for the cloud and Kubernetes native Java app dev. So you're going to start as a developer, and then Quarkx actually provide a bunch of the benefit and feature, specifically container design first, which allows to have a reduced memory footprint and super fast startup time, as well as a smaller memory and disk footprint. And so once you packaging application, you can run the application with the two different options. For example, you can still with the traditional way build the jar file and then running on JVM, but also you can package native executable file and running on VM rather than JVM. And also Quarkx provide a bunch of the Kubernetes extension. For example, like a Maven dependencies, which allows you pretty easily integrate Kubernetes resources into your Java method and classes. Okay, let's jump into the demo, how it works. So first of all, here is the very easiest way how to get started Quarkx application development. You can go to code.quarkx.io and then you can see the initializer of the Quarkx code generator and project generator. And you can select any extension you want to add, like a capability, like a less easy for web application or data transaction, and then messaging processing. There are more than 500 extensions available right now, and you can edit it and generate your project. Once you generate a project, it automatically downloads the zip file on your local file system, and you unzip file and then just open any your preferred IDE, just get started application development. But today I'm going to use a little bit different and funny way and an interesting way in a Quarkx CLI. You can download the Quarkx CLI, you can install like a JavaScript, like a JVM. Once you install Quarkx CLI, it allows Java developer to have the same Maven and Gradle capability, like a build, packaging, and add, and testing. But it's pretty easier. You don't even remember all Maven or Gradle parameter and arguments. It automatically complete all relevant command line in a second. So here's how to create new Quarkx project from scratch using Quarkx create command line. Let's say the project name Kubernetes-Java. Once you create, and it automatically generate the Maven wrapper and some of the configuration and the Docker files in case you're going to deploy application to Kubernetes, and also the sample application like a REST is reactive to expose your RESTful API like a hello world. So I'm going to open my VS Code to showcase my application. So go to pom.xml, it's the default. And then you can find the current Quarkx version, and there are default dependency which allow to download my local file system. So one of the beauty of the Quarkx provide the reactive mechanism and behavior. As you can see, Quarkx dash rest is dash reactive. It allows I can develop reactive application, but also you can develop imperative application at the same time, which means same method and same class. Using just injection or the request response processing, which is really good for developer. Under the source directory, you can find the Docker directory, which showcase the bunch of the Docker file automatically generated. For example, Docker JVM, you can run and build the Docker file images based on job file. And here is a Docker file native. Once you build the native executable file, and it just packaging job Docker image based on the native executable file. So this is one of the great benefit of the Quarkx framework and the Quarkx CLI or even code generator. So developers don't care about how to create my Docker file based image and runtime image as well as my application. And then as you can see, there are runnable executable file. Here is just a sample generate file like a Spring controller. And this is we can say a resource file because this handle HTTP request. So for example, here the hello endpoint and the return just rest easy hello. So I'm going to start Quarkx demo. This is one of the beauty of the Quarkx for developer. So once you run your Quarkx application as a local environment, it takes a few seconds, and then in the end, you have a live coding capability based on Quarkx dev mode. What is the live coding capability? Just in case you never ever heard about that before. So as you can see, profile dev activated and then live coding activated. So when you press W from the terminal window, it automatically open new web browser or tab menu and then showcase the landing page just like this. And then here is the BG dev UI and the endpoint. When you click on that, and your endpoint hello from REST is reactive, which is cool. And then click on BG.dev UI. So traditionally, a lot of developers a little bit hard time to figure out which dependency I already have on my application project, but also sometimes you forgot it existing dependency. That's why you got some conflict, duplication, or you cannot manage easily all dependency on your same project. But this Quarkx Dev UI showcase graphically more easily all dependency in one single nice page, but also it got a lot of capability inside this Dev UI. For example, you can click on Computer Editor, and it shows all application property on runtime environment and built-in environment. And when you actually open the left-hand side bottom, and you can read only UI for the logo message, and back to the terminal window, you can press R. It rerunning your continuous testing. This means the Quarkx automatically keep testing your test scenario as long as you define test cases under the target directory. You can go back to WI and then you will see all testing passing. This is a really great feature, not only non-Kubernetes cluster, but also Kubernetes environment. So as a part of the typical in-loop process for application development, a lot of enterprise architecture really highlight we have to need to go with the test-driven development. But most of the developers have no long enough time to add a new test cases, sometimes to skip it. But no one actually check that out in the development environment. Sometimes you got some error because that application code or compilation only working on the individual developer environment, not testing environment, not production environment. In that case, sometimes it causes huge incident in production environment because you have normally fantastic CI/CD pipeline. Once the developer commit and push that code into central GitHub repository, it will automatically compile and deploy to production environment in next 3 minutes, which is like a time bomb. So to avoid the kind of unexpected error or incident, you have to spend more time to build test-driven development from developer local environment. But this is really hassle to set it up all kind of test infrastructure in individual developer environment, but also testing environment. So Quarkx actually provide a out-of-the-box continuous testing capability with that. So whenever you change the code, it automatically showcases that. Let me show you real quick how it works. When you click on the test result, and you can find the green color, which means all good. So now I'm going to access the endpoint using HTTP command line from terminal window, which is the same. Let's change the code. For example, I'm going to change the return code like a hello Kubernetes Java, just like that. I just save a file and then back to the terminal window and just to access to the RESTful API. And I'm going to the result hello Kubernetes Java, which is cool. But when you go back to my runtime terminal log, you can find that some error just happening based on continuous testing capability. When you go back to dev UI and reload that page, you can find the same error. Here, the expected result and actual result. So, for example, the actual result in a hello Kubernetes Java, but the expected result hello from less is reactive. Because when you go back to IDE tool and then getting results of test cases, you can find that is original test cases. So you just automatically find out. But here's one more thing. Maybe you just surprised because in the meantime, I never ever try recompile, rebuild, and restart, and even redeploy my application. I just keep changing my code. That's it, and save a file, and just invoke the RESTful API continuously. In the meantime, in the behind the scene, Quarkx framework keep changing my application, such as in a process, just packaging, deploy, and restarting automatically, just like a magic. And then continue testing as well. I'm going to just change the test case, and it instantly test case is passed with the green color, which is really cool. So this is one of the great feature, not even 100% related to Kubernetes native, but you know what? The Kubernetes native Java environment, you're going to really fast develop testing and deploy in the Kubernetes from your local environment. We do that kind of developer experience feature, which is really helpful for developer to catch up, handle new business requirement implementation. So now I'm going to stop the dev environment. Let's try to packaging the application using Quarkx CLI or Quarkx build. So once I'm using Quarkx build, which is really same command line like a Maven compile or install, and then you can see unit test automatically start, but we already fixed all test cases. So that's why we succeed test running. And then once you build configuration, and then now we have run Java command line to run my microservices Java file. For running the application, let's take a look at my activity monitor on my local machine. As you can see, there are more than 6 Java applications running right now. And then you can see there are 194 JVM memory, and the other one is 79. The reason why I want to showcase this one, once you run my Quarkx application, you're going to see another new JVM is running as a memory buffering. Okay, let's go back to terminal window and then return and running my application. As you can see, it's less than 1 second to start up running on JVM. And back to the activity monitor, and you can see 88.1 megabyte for the memory buffering for the running application. Let's try to access the RESTful API to sanity checks and then the application return, and then you can a little bit increase memory buffering from 1880 to 91, like a 3 megabyte increasement for the memory buffering. Okay, I'm gonna stop it, and then I'm gonna try to packaging this application as a native executable file, as I mentioned earlier, which is really a good benefit and a feature to deploy application in Kubernetes, specifically like a serverless or high scalability use cases. For example, you want to deploy one simple application, but in that case, in some of the case, the application should be scaled out more 100 or 1,000 pods at the same time. In the case, the native executable Java application, which is really cool for that use case, is why. Let me show you. So I'm gonna package it once again, but in this case, I'm gonna pass down one parameter like a dash native, which allows Java developer packaging this application. Behind the scene, it will packaging the Java file as a first step, and then we're gonna use GraalVM compiler to create a native executable file. And it takes a little bit longer than general build application, because once you build the jar file, like a fat jar, and then we're going to create a new executable image which contains all dependency and the required library at the same time, just like imagine the container image. And then once we're done, we're going to test once again based on the native executable test case scenario as well. When you go to target directory, you can find the one executable file. And then let's try to just run without Java command line because this is actual executable file. And now you have 21 millisecond to start up and then running on native environment. So previously we almost less than 1 second, 0.9 second, but this is almost 40 times faster than startup time, the existing Java file, super fast. This is really fitting in the serverless application, specifically cold start strategy like Amazon Lambda or Knative on Kubernetes. Okay, so back to the monitor your resources, and then now we Kubernetes Java runner, and now 8.7 megabyte, and let's try to invoke REST API to check functionality, the same result, and it slightly increased 9.6 megabyte, which is almost 10 times less than memory footprint. So here's the thing. So you have two choices, but you don't need to packaging native executable all the time. But specifically, you need to scale out application, maybe 1,000, just like I said earlier. In that case, this is all about money and cost running on the same application with high scalability and a super fast running time and startup time like a serverless application. So this is one of the great feature how to develop a Kubernetes native Java application with Quarkx, specifically Java developer. So I'm going to stop it, and now I'm going to deploy this application to Kubernetes. Let's say I just done application development, and now I'm going to deploy application. So in order to that, traditionally you have to create container image based on Docker or Podman, and then also create a bunch of the Kubernetes resources file and a manifester to deploy Kubernetes cluster. But here's the thing. So Quarkx provides OpenShift extension, which allows developer generate all required Kubernetes and OpenShift resources at the same time pretty easily using just a Maven command line. So I'm going to use Quarkx CLI, Quarkx ext, and add OpenShift extension. It's automatically downloading all required dependency on my local file system. And now I'm going to try to add some configuration my application properly. As you can see, there are a bunch of the configuration. For example, OpenShift extension configuration. I'm going to deploy target environment OpenShift, which is one of the enterprise version of the Kubernetes. And then I'm going to deploy this application. It automatically exposes route URL to access to the actual RESTful API from local to the remote Kubernetes cluster. And then here's the interesting part. So once you deploy application to Kubernetes, how to troubleshooting if you got some error in the production environment. You gotta just try to reproduce the same error on your local machine, but sometimes it's not work. It's not easy to produce the same error on your local machine. So one of the good thing of the Quarkx actually you can debugging or run the DEM model like a live coding capability from local to remote cluster. Let me show you that. You're gonna add one environment variable, something like the Quarkx launch DEM mode true, and then we're gonna keep changing the application automatically, just like a live coding, into running pod on Kubernetes. In order to that, we're gonna packaging type mutable jar. You probably know that one of the best beauty of the characteristic and behavior of a container technology is immutability. Once you packaging application, you cannot change that. Even you can change that, but when you restart the container, it automatically restore original snapshot. But we're gonna make it change it continuously. That's why we put in the package type immutable jar. And then we're gonna set it a password URL to connect between my local, the remote cluster. So that's it. And then I'm going to save a file and then go back to terminal window. And then I'm going to just to build once again. I'm going to just close my dev UI and local environment. Here's my OpenShift cluster, which is a developer sandbox. When you go to developers@redhat.com, you can sign up for free to get one single OpenShift cluster based on latest Kubernetes version. So I'm going to make sure I already log in my OpenShift cluster and develop sandbox of my project in DOH dev, just like I showed the developer sandbox. And now I'm going to run, so again, Quarkx build. In this case, we already edited OpenShift extension, which is going to be trigger OpenShift source to image process that create a new container image and a bunch of the OpenShift manifesto, like a build config, image stream, and an actual image, and so on. It basically using Docker file we already generate our project, which is cool. And then once you're done, and then you're gonna push new image into OpenShift container inside the container registry, and then in the end, the OpenShift cluster, aka Kubernetes, just pull down new container image into available worker. So now the application is running, and click on the view logs you can find, and then the Quarkx basic logs, and then here's the interesting part. The profile dev and the live coding activated just like your local environment with the Quarkx demo. Okay, go back to topology view and then copy my route URL to access the application. You can actually click on that and then go to landing page, just like your local environment. And then I'm going to change another terminal window and then access to my RESTful API like a hello, and then you can hello Kubernetes Java, which is cool. Now I'm going to update my URL to access to which Kubernetes cluster I'm going to connect to and a remote Quarkx step. So, and then I'm going to run Maven command line Quarkx remote dash dev. So Quarkx CLA actually doesn't provide this capability at this moment. So that's why I'm going to use the Maven command line, Maven Quarkx remote dev. Once you run, you can see the remote cluster is connected. Okay, now I'm going to try to change my application. Let's say I needed to new business capability on my application and running onto the Kubernetes, just like troubleshooting or add new features. Okay, I'm going to change my return code, hello Kubernetes Java at CDS22. I just save a file, and then I'm going to just access to RESTful API, and then back to the terminal, and then you can see automatically detecting changes to class and the file and the packaging job file, and then push it into OpenShift cluster, and then you got the new result instantly. It's just happening in 2 seconds. And then I didn't packaging or create all Kubernetes resources and redeploy. I didn't do that anything. Just Quarkx automatically do that for me, just like a live coding capability from local to remote cluster. But sometimes people curious about, you just change one single word on your existing method. What if you could add a new method or class? Is this still working? This remote dev mode from local to production environment? Just FYI, I'm not gonna say you need to use this kind of feature on your production environment. This is more like a testing environment to figure out from your functionality on your local and production environment. At the same time, it reduces your inner loop process development from local to Kubernetes cluster, which is now default the part of your inner loop development process. Okay, so let's change that for the that cases. So now I'm going to create a new Java class like a greeting services Java file to define like a CDI bean. I'm going to add an application scope for this Java bean, and then just create a new public method, just to return simple context like a greeting, and with a parameter like a name. So I'm going to return new text, for example, welcome to CDS22 and Kubernetes Java with the Quarkx, and then I'm gonna append the actual parameter name. Okay, pretty simple. I just save the class, and then back to the resources. I'm gonna add the Cdi injection, just like for example, in a Spring space like AutoWire, but the Quarkx used more explicit term for the injection, like inject annotation. And then I'm going to use compute property. So for example, this is a known practice how to set your computation and reading that like a specific parameter from your computation file rather than dynamically passed down from URL like a get method. So I'm going to use a compute property annotation. I'm going to read that variable from my compute file. Let's say username, and then the string variable is a username. And now I'm going to create a new RESTful API here. Return text plain in a new path like a username. So in the end, the actual RESTful API hello/username, and then let's say the method name like a greeting, and then I don't need the parameter because I'm going to read the username from my computation file. I'm return and I just invoke the CDI bin file like a G services in the greeting, and then name which is referring to my computation property. Let's see. I just save a file, and then let's go back to application property. I'm gonna set the username, which is my name Daniel. Just save a file. That's it. And then go back to terminal, and then let's call the new RESTful API hello/username. This is running on the remote Kubernetes cluster. Just keep in mind that. And then I just run, and then you got a new result, welcome to CDS22, and then that kind of stuff. And then you can see automatically packaging the bunch of a file and then packaging job file and then push it into OpenShift cluster. And now we gotta try to another use cases here. For more Kubernetes native characteristics. In a lot of cases, I just show how to refer your specific value from local file system. But the beauty of the Kubernetes, you actually use config or secret to save and store specific information. The secret really more focused on sensitive information, for example, username and credential and token, etc. And the config more general configuration key and value. So this is a more best practice how to develop Kubernetes native Java application rather than referring to static configuration file. So I'm going to create a new config based on web console. You can actually use that like a kubectl CDL. But this is one of the beauty of the OpenShift cluster, by the way, showcased and then provide the web console. You can easily create a new config map. For example, I'm going to create a new config map username. Let's say the data name is the username.alias. My preferred name actually Dan. So I'm going to just set my alias name Dan. I just deleted the other one. I don't need that thing. Okay, I just save a file. So my new config map is a username and actual key username.alias and the value is Dan. Now I'm going to add a new Kubernetes config extension, which allows developer to refer your config map or secret on the remote cluster from your Quarkx application. It's cool. And then now I'm going to add a few more extension here and compilation based on Kubernetes config extension. As you can see, I'm going to enable my config map reference. And then the config map name is username, and then my current working namespace in DOH-dev. So then back to here, and I'm gonna define new config property using config property annotation, and the name equal is that alias key name, username alias, and then let's say the actual attribute name is alias name. Okay, looks good. All right, I'm going to change my existing method. You can actually create a new method for REST API. I'm going to change that. Just pass down reporting alias name. Okay, save a file and just invoke the same RESTful API. So now you can see the same prefix, welcome to CDS22 and Kube native Java Quarkx, and actual the parameter is Dan. It's not gonna from my local file system. It's more like from Kubernetes config map. You can also add more secret reference as well. This is one of a great way for Java developer to incorporate, enable, and refer some information from Kubernetes resources such as config map secret on your Java application. Okay, so that's it. That's what I want to showcase today with the how to develop Kubernetes native Java application with your Quarkx from your local and seamlessly having same capability and experience on Kubernetes cluster as well. If you feel a little bit more not enough to learn about all kind of stuff, please feel free to subscribe my YouTube channel. Here's your QR code and then a bit.ly URL, bit.ly Daniel TV. I already published a lot of technical demo video, including this, but also a bunch of stuff. For example, how to develop serverless application from multiple cluster and fast platform such as Amazon Lambda, Azure Function, and then Kubernetes Knative. Thanks for joining my session. If you have any question, feel free to reach out to me directly using Twitter and YouTube channel. Thanks all and enjoy the rest of our container days.